All right, and there is few different types of constraining. So go back, and let's delete this constraint. I, for example, can constrain all of my, well, again, using a wire pin. I can do something like this. Constrain all the perimeter points. Hit enter. So now it's holding up like this. And if I create, let's say a sphere again, turn it into polygon, increase frequency, and then turn it to class. And let's turn this class into something really, really strong, like almost like a static, like a metal sphere. Yeah. And now you may ask about why it's not tearing. Well, there is a sad moment that I talked in the beginning. The side effects cut out few features. They cut out the tearing and plastic deformation. And they're promising to bring it back really soon, but nobody know when. Yeah. So normally this sphere should tear this grid and fall down because it's really heavy. So, plastic deformation was about, for example, if I drop the sphere like this, so the grid will stay in this form for forever and not going back. So this plastic deformation could be used for example, the crashing cars or something like this, or simulating the metal can which is heated by something or something like that, like so. But currently we don't have this. Okay, I will disable my sphere. Let's delete the pin constraint. And here is a wire spring constraint. So I hit on this and it asks me about select dynamic points for wire constraint. And let's say I want to select those in the center. Hit enter. So now you see it's almost like on spring. And it's possible to control the parameters of the spring. So let's say really weak spring, and it's stretching way more. Yeah. And if I make it stronger, it goes like this. And you see it's wiggling a bit. Oh, probably it's too strong for now. Yeah. So you can play with all the parameters here to find what you need. And here is even more constraints. So yeah, and all of them are pretty self-describing. And yeah. Okay, but let's say I want to Yeah, okay, let's talk about this buttons here. So next after class is deforming collider, and that's a recommended way to deform class by some geometry. So again, let's create a ground plane and create a sphere. And now let's say I don't want to convert my sphere to class, but I want it to collide with. And as I talked previously, it's better to use two class objects to interact with each other than RBD and class. So I select my sphere and convert it uh, to collider. Yeah. Well, uh, that's strange, but who didn't convert my sphere to static object the same way like here? Well, all right. And rigid collider. Okay, let's create a rigid collider. It's disappearing, but it's here. Well, it's hard to tell what's the difference between these two, but all right. And the next button is attach class to the body, and right, I will create an object. Oh, okay, let's let it be a tube. Polygon, and let's do it like so. Make it bigger, and let's bring some animation to this sphere. Let's say something like this. So it's just a simple rotation. And let's constrain the class here to this tube. So I select nothing and hit attach to body. And it asks me about select the class object. So I select my grid and hit enter. Now it's asking me about selecting the class points. And let's say I want to constrain those. Hit enter. And now select dynamic object. And I have no dynamic object. Okay, I need to create a dynamic object first. So I select my tube, deforming object. Okay, it has the animation. So let's try it again. Select the grid, select the points, and okay. Right, so now it's converted. Yeah, and my sphere is disappeared, but you see that it's interacting with glass. Not sphere, but tube. Okay, so now let's attach. Select this, enter, select those, and then okay, now it should be constrained. and it looks like this. So I actually hate that my tube is disappearing. Well, at least like this. So yeah, it's constrained because you see the grid is like magneted here, and it's now it's spinning together with tube. So this is pretty handy because normally you want to attach close to something. Yeah. And follow target. Well, it's doing the same like I did with clause constraint, but let's try. And I hit flow target, select clause object. Okay, enter. And it doesn't like something. Oh, sure, because I removed the clause. Okay, follow target, select clause. Now select clause points, and let's say I want to constrain those. Target. Um, So, all right, the issue with was in guide options radius, so it was really small. So, and the behavior of this follow target constraint is that it allows to let some points which are constrained to stay in the place. And I played with stiffness and damping parameter here. And if I bring it to default, these points will stay on place no matter what. While if I decrease the stiffness and play it, it will be dragged a bit by main geometry. So this can be used for some effects. Stitch clause is for merging two claws together. So I will take my tube and convert it to claws like this. So now it's falling all together, and yeah. Oh, and the problem here, you see that when I'm starting to play the simulation, the tube is losing the caps. It's easy to fix, and the reason why it happens because after I create the tube and apply the caps on here, these caps and the main body of the tube is not merged together. So basically I have three different geometry in one. And that's normal for Houdini, but can cause a lot of problems. If you don't know about this, let's say feature or bug, I don't know. For me, it's bug. Uh, so to fix it, you need to create a fuse node. So now it's merged all together. And when I play the simulation, it's not flying away. Okay. Now let's try to stitch these two claws together. So I will click on stitch clause. Okay, and now it's asking me about select clause object. Hit enter. Now select clause points you want to constrain. So let's say those. Enter. And now select the dynamic object to stitch to and hit enter. Now select points, okay, like this, and let's play. Yep, and now it's merged together. Yeah, here you can see constraint object, call object, and points. So as I told you before, there is a way how to check the and yeah. So when I'm start to play the animation, it's really trying to pull them together, and it's collapsing to each other. And even if I have collide with self, it's not really help. So it's better to have two claws aligned to each other. I mean, those points you want to constrain to. So like this. All right, so now it's working. Class proxy, and all right, let's select the any clause here. Let's remove this. And class proxy, select, and it's asking about geometry. And something like so. Okay, to show how the class proxy works and what it's for, I've created a new scene with yeah, we'll start from scratch. I'll create two grids, and one of them, let's say, really high res, like this, and second one is just 10 by 10. All of them are placed together, like this. And let's turn the grid object 1, which is high res, into cloth, like this, and play the animation. So yeah, you see it's falling down, and it simulates. Now let's create a class proxy, and to do this, uh, first I need to select the low res, hit enter, and then select high res and hit enter. And you see that the low res get the same position as my class, and it simulates together. So it's like a warp deformer in Maya, and my high res become invisible. So it's resource saving feature, because if you have a really high res cloth and you need to show it in viewport for each frame, it can slow down a lot. While this one, okay, let's create a ground plane, create the sphere, convert it to polygon, like so, and then convert to deforming object. Yeah, well, it's here. And now you see I have high res and low res on the same time, but if I go back to object level, I see only a high res. Yeah, while the simulation happens for I see only low res, while the simulation happens for a high res. Okay, and the last node here is distribute, which allows us to render, um, simulate class or fire effects or water on few machines, but this feature is not working in Apprentice HD or Apprentice Houdini, and that's the version we have at school. So unfortunately I can't show up how it works. However, this is a really nice feature, because if you have a lot of machines, it can save you a lot of time. Okay, and now, as I promised in the beginning, we'll create the scene with flying claws. And to do this, let's create a ground plane. Why it's not showing? Yeah, okay. Well, yeah, well, at least like this. Okay, ground plane, and let's create a sphere. This ain't funny. If you have something like this, probably you can change in preferences. You could go to 3D viewports and change scene render from GL 3.3 to 2.1. Yeah, and it works. I just forgot about this feature. Well, not feature, but solution. Alright, and I have a sphere, so let's convert it to polygon. Increase frequency, just for nice view. And let's lift it a bit. Okay, let's convert it to a class object. Cool. And now let's create a wind force. And let's apply some value here. I'm applying it to y, x, y, z, and let's play animation. And you see, because class here is really soft and stiffness is low, it's going up and it's deformed like this. So let's change the values, and I need to increase stretch and overall stiffness a bit. Well, still too slow, too small. And maybe a bit of strong, not strong, but weak band. Well, for example, this is just a test, so you get the idea. Okay, better, and overall stiffness and a bit of damping. Yeah, okay, that's fine. And let's create a box, a simple box, convert it to deforming object, and nothing happens to this box. So let's lift it a bit, for example, like this. Well, no, actually I need to convert it to class also. So let's convert it to class too. And now you see the box falling down and the sphere is coming up, just because the force, wind force, is applied before the box and sphere merged and sent it to solver. Alright, and now I need to create just a basic constraint, which I showed you a few minutes ago. So we go into wires, and here I need to select attach constraint to dynamic points. So I hit this, it asks me about select constraint to attach constraint. Alright, and now I need to create a basic constraint, which I talked a few minutes ago. And let's create attach wire to surface, and select box, enter, select vertices, enter, select sphere, enter, and now let's select well, just a few points here and hit enter. So now I have the constraint, It's not perfect, but it should work. And let's play. Okay, and that's now it's going up because the box object is really lightweighted. Okay, so uh, let's make a wind force weaker. Like so. So yeah, the force is too small and there is not enough power to lift it up. Okay, and to fix it, so you see if I have the scale force uh, 0.1, that's enough power. But if I set to 0.01, that's not enough. Alright, so something like this should look nice. Yeah, and let's say from frame 70, I want to increase the scale force. So let's write an expression here. If $ff smaller than 70, the force equal to this. Otherwise, the force will be like this. Alright, and let's play the animation. Alright. And this is not working because here in the wind force and in any force there is a default operation set initial. And to make this work I need to set always. So this will update the value. Let's play now. Yeah, and now you see that force is increased, but that's still not enough. It's lifting, but really slowly. And right, let's increase it a bit, like so. And still not enough. That's strange. Okay, 18 should be still not enough. 3. Well, 0.5 I believe should be enough. Yeah, it's lifting. And the ropes are stretching. And now, yeah, you see it's pulling it up. Um, Probably it's possible to play with constraint type. So if I set to hard, whoa, now it was a bad idea. Yeah, here I can control the strength. So let's say I have in wind force I have 0 to 40 and 0.8. Okay, and if I increase the strength of the constraint, this shouldn't stretch. Yeah, so when it's enough power, that's not stretching that much, and start to pull it immediately. And yeah, it's stretching, and start pulling. Yeah, that's because the strength of the constraint is really small. And here you can see that we have two interesting parameters, which which uh, which called limit force and limit length. So I believe if I set the maximum force to something small, and when my sphere will start to pull the constraint up, this should break. This should break. Okay, just for testing purposes, let's increase mass of the box a lot. Yeah, it's so heavy, so it's even falling down. And let's increase lifting power to 3. I'm actually expecting one of two things. Either this will break or the cloth will lift up. And no, nothing happens. Alright, you asked for this. That's extreme value, but I really want to make it work. Okay, let's play even more with force. Limit force, limit length. It's a bit hard to work because some of these values is just abstract numbers and they are not connected to real numbers. And actually the side effects recommends to have the class simulation in real size. So for example, if you simulate a t-shirt or something like this should have a real size because only in that case you will get the best result. And yeah, okay, you see that it's trying to pull the claws and yeah, it works. Hey, so this can be really interesting. If I set the force to bigger result, damping too small, limit force. So yeah, the strong constraint is not allowed to stretch too much. And you see that the behavior of the box become really interesting. And I'm just wondering what will happen if I limit the length of the constraint. Uh, okay, it looks like it's limiting the actual length, and even if the constraint is going to stretch a lot, this will not allow to do this. Well, yeah, well, you see it, some of the parameters are really strange and not working as you expect it to. But if you spend a bit of time with this, you can find the way how it works. Alright, so that's all about claws. And in next lecture we probably will talk about, I don't know, something else. So thank you for watching and see you next time.